So, metabolism, what is it? Most people's closest contact with it is someone saying they have a fast metabolism and that's why they can get away with eating a lot of stuff and still be skinny. For those with a little experience in biology, that word might awaken some war flashbacks from something that looks a little like this. Yeah. Well, I'm here to make the case that metabolism is not only fascinating, but that if you look at it the right way and put in a little effort, it's not as impossible as it feels at first. So, with that out of the way, again, what is metabolism? Unrelated question, what's a carb? You might answer, carbohydrates are a large class of the biomolecules that constitute life. They can be generally split function-wise into energy storage and structural functions. If you're not a nerd, your answer is probably closer to, sugar, yummy. While that answer might satisfy a 5th grade science teacher, it doesn't satisfy us. So let's dive deeper. This is a glucose, also known as sugar, kinda. It gives energy. But how does a molecule give energy? Does it have energy? What even is energy? Okay, I'll stop you there. This is the unfortunate point in the video where we have to acknowledge physics exists. Now, the average person watching is either interested in biochemistry or is normal. Either way, bets are you don't like physics. And trust me, neither do I. However, such is our fate that we must dip our toes in this forsaken field of science. So, energy. What is it? Talking broadly as a not physicist, it's the property of stuff to do things. So, the more energy you have, the more things you can do. Something you might have heard is that energy cannot be lost or gained, only transformed. Transformed? How? Turns out there's a couple of different types of energy. Last I checked, at least 3. So let's meet the team. Mechanical energy is the jock of the group. Shows off the most, looks like a real tough guy, but in reality he's pretty easy to understand and manipulate. In general, this is the energy we're going to be using to just move around. Now, chemical energy is the nerd. He does all the work just for some asshole jock to beat him up, copy his homework, and steal all the credit. Chemical energy is basically the energy held in a chemical bond. It's most easily explained by looking at why reactions happen in the first place. All molecules really just want to chill and get rid of all this energy. So if they notice that binding together or pulling apart will decrease this energy, they'll do it in a heartbeat. And each molecule will lose some energy and be a little happier. This criminal just said that molecules will lose energy, when, as we all know, energy cannot be lost or gained, only transformed. Fret not, for physicists also noticed this crime and invented a solution. Thermal energy is the energy inherent to temperature and is the reason why molecules can react without going to physics prison. When a spontaneous reaction happens, some amount of energy is released as heat. However, as far as we're concerned, this energy might as well have vanished off the face of the earth because we're never seeing it again. Continuing the analogy, thermal energy is your father who left your milk and stole your savings. Okay, that's enough physics. Now, with our enhanced knowledge, let's come back to the question at hand. How does a weakling beta molecule like this glucose let you bench 100 kilos? Well, we still have no clue because this is a molecule. It has chemical energy. We need mechanical energy. Thanks for nothing, physics. Still, even after this brutal betrayal, this whole lecture wasn't pointless. We can use our newfound knowledge, but first we need to check out another field of science. This whole biochemistry thing requires so many different sciences, you could almost call it a science of many fields. Anyways, biology shows us that, in fact, making mechanical energy out of chemical energy is light work. Even dumb proteins can do it. Example. This is a membrane of a cell, also called a lipid bilayer. Why is it called that? Here's a lipid, here's a layer of them, here's 2 layers. But this bilayer is actually full of stuff. One of this stuff is proteins. Look at this one. It goes through the membrane. Actually, this is no protein. It's a nightclub security guard. When someone comes over, hands their ID, and is generally giving good vibes, the guard opens the door and lets him in. But if some kid comes around being like a general asshole and also clearly an underage, the protein says nuh-uh and doesn't let him through. Well, I mean, unless the cell is in the Balkans. Anyway, what are we talking about? Energy, right? So this door opening business very clearly takes mechanical energy. But where does it come from? Turns out, every time the door opens, this mystery molecule comes around, breaks a bond, and nudges the protein over, transforming the energy from chemical to mechanical. Not so hard. So who is this mystery molecule? Let's go back in time a little, like 3.5 to 3.8 billion years ago. This is a cell, mostly. He hasn't been a cell for long, but he knows his physics, and he's figured out all this magic molecule business. Now he just needs to find one. This cell likes to eat soup, and in his soup, he sometimes sees this weird structure. It's called a pyrophosphate, or diphosphate if you're not metal enough. If you break it in half, it starts to get a little warm in here. From our physics lesson, we learned that this means that now we have a bunch of thermal energy, which means that this bond had a bunch of chemical energy. Turns out, it's quite a big bunch. Look at our little scientist cell, so proud. But wait, if this diphosphate has a bunch of energy, why don't we then add another phosphate and get a triphosphate for even more energy? Genius! But wait, if this triphosphate has a bunch of energy, why don't we then add another phosphate for even more energy? No, that's enough, you're getting greedy. But this triphosphate guy is kind of weird to handle, and our cell already has a bunch of this stuff to make its DNA, and it seems pretty good at holding phosphates, so why don't we just... Cool. This bit we know is a triphosphate, that's called an adenosine, so we can call this guy adenosine triphosphate, or ATP. Wow, that's so cool, said the cell. I'm sure this won't have any long-lasting repercussions I couldn't possibly be aware of. Every single living organism uses ATP as its main source of energy. Damn. Appreciating the beauty of evolution aside, this is great. We have our magic molecule, we only need to turn the glucose, remember him, into ATP, which should be easy enough. Wrong! It's not easy at all! In fact, it's so not easy, it gets its own name. So we call the chunk of metabolism that deals with making what you eat into ATP, catabolism. The other part of metabolism, using said ATP to make new stuff, we call anabolism. So what is metabolism? It's all the biochemical reactions that make your food into ATP and then make ATP into everything you need. Okay, but that's a boring dictionary definition. What metabolism actually is the factory of life. It is what makes this whole living thing possible. And that's why I wanted to share all of this with you, because I know most people either know nothing about metabolism or are genuinely terrified of it. But to me, it is the reason why when I look at this, I don't see a pile of reactions. I see life.